This is the Worksheet 3 companion video. In this video, we're going to work through the practice problems in Worksheet 3. And before we get into that, we're going to just talk about some of the content in general. I am guessing that this video is probably going to be split into 3 parts. I think the first part is going to be talking about the new content, the new concepts, and working through a couple of the practice problems. Then practice problem 5 will be its own video, and then practice problem 6 will be its own video. So, don't hold me on that. Sometimes I end up splitting them up into even more videos if some of them start to go a little bit long, but I'm guessing probably 3 videos for this worksheet. So to begin, worksheet 13 is just going over more array concepts. We're going a little bit deeper into arrays. We're introducing some new types of arrays. But I am going to refer a little bit to the PowerPoint for this week. Arrays Part 2, multidimensional arrays, because the multidimensional and parallel arrays are what we're going to be kind of focusing on this week. So what is a multidimensional array? They just kind of build off of the arrays that we worked with last week, the one-dimensional array. If you've ever kind of studied, art or what dimensions are, excuse me, we can think of a 1D array, or just sometimes it's just called an array, is just a collection of elements, just kind of like in a straight line. Where a multi-dimensional array can add different, I hate to use the same word, but dimensions. So this would be an example of a 2D array where we don't just have rows, but we have columns added into it too. And the analogy that most people use for a 2D array is like an Excel spreadsheet, where rather than just one row in Excel spreadsheet, we now have, different columns with that. So, and it can go into even more dimensions. There are 3-dimensional arrays too, and there are reasons why you would want to use that. We never get into 3-dimensional arrays in this course, but be aware that they do exist. You could think of a 3-dimensional array, again, kind of like if you've ever worked with Excel. Inside of Excel, you can have one Excel sheet, but then you have tabs to have like multiple Excel sheets in the same file. And like those tabs would be kind of like the extra dimension where it's not just one sheet, you can have multiple, and you can almost think of it put together like a cube of elements. So let's see. When we usually set up a 2D array, usually the data is related in some kind of way. So like each row is related data. So like if we're thinking about like a game with a player, a row could be like a bunch of players. So like the first column would be the name, and then the score, health, and then the next row would be the next player with their name, score, and health. Like they all need to kind of relate in some way. So that's one thing to keep in mind. Like don't just randomly throw your data in there. They all need to align up in some way. And as we work with it, you're gonna see how that works. And just as a note, you can use .length in your 2D arrays. But what .length does in a 2D array is it just returns the total number of elements. So if you think back to how we use .length with our 1D arrays, like our regular arrays, we were using .length in our looping, like our for loops, to make sure that we stepped through our arrays. But we can't quite use that in our 2D array, because if we have, like for instance, this array, it's not going to return like, I guess it would return like 4 and 3. That's not how it would return. It would just return the number 12. And if we're trying to use a for loop to step through that, that's not really going to work. So it's still useful to potentially know how many elements are in your array, but be aware that you're not going to get the information. We won't be able to quite use it in the same way as we did with the 1D array. So this is just kind of an example of that. And we declare 2D arrays in a specific way. And make sure that you understand how to declare it this way, because there are a couple other similar approaches to arrays where if you declare it slightly different than this, it will technically work, but it won't necessarily be what we think of as a 2D array. It's very easy to accidentally make an array of arrays, and that's not really what we want to do. So the big difference in declaring a 2D array versus a regular array is we need to put that comma in the middle of those square brackets. And then on this side, when we are telling it the rows and columns, it's the number of rows, comma, the number of columns. If we kind of look at this, the number of rows versus, and we'll kind of work with that, a little bit. So this would be, 3 rows with 4 columns. And honestly, as long as you keep track of what data is supposed to be in which area, we can kind of set up our arrays however we need them. It's just you need to be kind of consistent. Think of these as rows, the first number as your rows, and the second number as how many columns. So let's see. We're going to probably skip a lot of this and just go right into doing some examples, but just be aware that this is here so that if you need to refer back to it or want some extra examples, it is in here for that. Let's see if there's anything else useful in here. We are going to go through processing 2D arrays with a loop, but be aware that we're going to be using something different than just dot length. We have to use it. We have to do something in a slightly different way, and because dot length isn't quite what we need to do with that. So we're going to go through, for loops. We'll do a little bit with for each loops as well, and let's kind of get started with some examples. So you're going to see the video pause for a second, but what I'm going to have in here is just my Unity scene set up. It's just a new project called Worksheet 13. We're not really doing anything in here yet. We're just writing to the console if we're doing anything. So just make sure that you get prepared, like a new C# file to work with in your scene, so we'll be ready to go. So let's begin. Again, Worksheet 13, C#, it's in my scene, and I have Visual Studio open, and we are ready to begin working through our problems. And for this, probably a lot of it, we're just going to use the start, and I'm just going to make, just for practice and to kind of make it easier to turn things on and off, my own void functions. So I'm just going to make a private void called practice. If I can type this morning, practice1. We're not going to send anything to it, and we're just going to do our practice 1 question in here. The one thing I do want to make sure I go back and do is call practice01 inside of my start. So if I do want to print stuff to the console for practice, it will work. So practice 1. Create different types and sizes of 2D arrays and practice filling them with data. So let's just do our usual int array. We'll make a 2-dimensional int array and put some data in it. And now that we're working in 2 dimensions, these arrays are going to get kind of big, so we're not going to necessarily do anything too large. I guess we can do a bigger one with our second one, but let's just kind of define one. So first things first, you need to tell the computer what data is going to be stored in this array. And just like single dimension arrays, 2D arrays always have to store the same type. So we can't have a 2D array that stores integers and strings, or integers, strings, and game objects. If we create an array, it has to contain all of the same data type. So we're going to have an int array, and it's going to be two-dimensional. So we need to put our square brackets, but to signify this is going to be a 2D array, we put a comma in there. It's going to, because that signifies that there's going to be an x and a y in our size. We then give it a name. I'm going to call it int array. We say it's equal to new int again, because that's the type of data it's going to be. And then in our square brackets, we have to give it the size. And we're going to give it 2 rows, 3 columns. Just like every other, just like last week when we started with arrays, one important thing to keep in mind is that the first element is 0. So if we were kind of going to define, like if we were kind of going to draw out what this should kind of look like, and I have Photoshop open so I can easily kind of do this real quick. Give me 1 second. And we think of our 2D array, as a box. And let's see, why is this working? There we go. So we said we are going to have a 2D array, and it looks like this. And however your mind's eye kind of sees this as far as your rows and columns, it can go 2 ways. I kind of, in my head, see them going, up and this way. Some people see them going down and to the right. It really depends on, what you're most comfortable visualizing it as. Since the directions, or the PowerPoint kind of has them going this way and down, that's how I'm going to draw that on here. So we said this array is going to be a 2 by 3. So we will draw, there's our 2 rows, and then our 3 columns. But what are the actual elements in this array? Since they start at 0, this would be row 0. This would be row 1. This would be column 0, column 1, and column 2. So in order to access this first element, we're looking at 0, 0. To go next, 0, 1, 0, 2. Down here, this is now row 1, column 0. Row 1, column 1, row 1, 2. And, if you're new to arrays, there's no reason why, if you're trying to figure out how to work with stuff, get a piece of scratch paper and draw these out. Sometimes it can help so that you don't accidentally mess up, because what's going to happen if you define a 2 by 3 and you try to access something like, we'll go really extreme, we want to go to supposedly row 2, column 3. What's going to happen? This is not going to work. We are going to get our out of range exception if we try to access that, because that does not exist since it starts at 0 for our element. So keep that in mind, that just like our arrays last week, if you try to access a element that doesn't exist, you're going to get an out of range exception. So with that said, let's pop back over to Visual Studio and let's fill this array now that we have an idea of what we need to do with this. So let's just practice filling a couple of these, and then we will use some looping to fill the rest of it. Just because it's going to get kind of tedious to fill 6 elements. I guess we could, but we'll just kind of work on a couple of them. So if we want to fill the first one, we'd have to say int array, square brackets, 0, 0 is equal to, we'll just say 1. What if we want to access the last array and fill it, the last element in this array and put some information in it? It would just be int array. Since it's 2 rows, 3 columns, it would just be that 1, comma, 2 is equal to 6. And, you know, we could go through and fill in the rest. But let's practice using, let's see. I guess we use loops later on, so I'll hold off on that. Let's create a couple other quick arrays, and we can just so we have some practice just defining them and filling in a couple of them. So let's make a string array, string, square bracket with our comma, string array is equal to new string, and let's make this a little bit bigger. We could do a 10, comma 10. So it's 10 rows, 10 columns. So how many elements would be in there? This would be a 10 times 10, so this would be a 100 element array. So we could really start to store a lot of information in here, and it's information that's easily accessible rather than trying to have like 100 variables. It's all kind of contained in this nice array. We can store information in here just the same way. So our string array, if you want to do it the first one again, 0, comma 0 is equal to hello. Hello work, no, hello world. We can access something in the middle of it. String array, 12, comma 66 is equal to something else. And let's practice accessing the last element in the array. So that would just be string array 99, comma 99, because remember it's one less. Oh, I'm sorry, nope. I totally messed this up. I'm thinking completely wrong. What would happen if I ran this? I would get an out of range exception, wouldn't I? Because I am not thinking. 5 and 6. And then the last element would be 9 and 9. If this was, you know, a 100 by 100, that would be a giant array. What would that be? Like 10,000? So sorry about that, but yeah, we would have gotten an out of range exception. Do you see how easy it is to accidentally think wrong with these? That's why it might be a useful strategy to draw some of these out and really think about in your mind's eye what the structure would look like if it was drawn, you know, in a, like a virtual, I guess, environment. Let's see. The end. There we go. So I think that's good for practice 1. It's just kind of a good way to warm up with defining some arrays. So let's move on to practice 2. And I'm going to just write practice 2 up here. And we'll define a new function down here. Private void. And let's see, what does practice 2 say? Practice finding the number of elements in the arrays created in the previous question. Okay, so let's just copy and paste this array into here. Since we defined this inside of practice 1, it is scoped to practice 1. So if we try to access it in practice 2, we can't. So that's why we're copying and pasting this into here so that it's the same information. We just don't want to type it all out again. But this specific array is now to here, and this one is still to here. So this is one that we do want to probably do some console printing just to see what happens. So let's do that first. Let's print to the console. Actually, let's do it this way. We'll make an int test length. We'll set that equal to int array dot length. And let's see what happens. Excuse me. So we should get 6, because remember, if we do just a dot length in a 2D array, it's going to give us just the total number of elements in this array, and that would just be 6. So we'll print results of dot length plus test length. And let's see what happens. If you need to, you can comment out practice 1, like if you're having some kind of error for some reason. I'm not, so I'm not going to bother with that, because the only thing that's going to be printing to the console is this. So let's try that. Let's see. I don't think that's a problem. We'll just clear that out. And let's hit play. So results of dot length is 6, and that is what we were expecting. So that's can be useful, but what if we are trying to, we use dot length with 1D arrays for looping so that we can easily step through our array. How do we do it so that we can just get the row number and the column number? There's a slightly different way that we do this. And the way that we do this is kind of similar to length, but rather than length, we use get length. And we need to specify, are we looking for the row amount or the column amount? And I'm going to show you how to do this right here. So let's just make some new ints just to store this so that it's a little bit more clear. So if you need to go back and look at notes, you know exactly what you're doing. Probably would want to comment some of this stuff to yourself too. We're going to get, let's see, we'll call it row length. And that all we do to do that is we say we want to do int array dot get length, but we need to have these parentheses. And inside the parentheses, we want to put 0 for the rows. If we think of this kind of almost as an array, and we look at how we define it, this would be 0, this would be 1. So if we do get length 0, we are looking for the rows. If we do get length 1, we are going to be looking for the columns. So let's do that for the columns below. Int column length is equal to int array dot get length, and we'll put 1 in there. Let's print this all out now to the console so we can look at our information. And it's always good to double check this. So we'll print column rows plus row length plus, I'll do a little bit of a space, column, I'm sorry, that doesn't make sense, column rows, array. Let's try that again, sorry. I need to drink a little bit more coffee this morning, I think. Array columns plus column length. And let's see what we get in the console now. Let's save it, hop over to Unity, and let's run it. So we get our length of 6, our array rows is 2, and our array columns is 3. And so we are getting the results that we are expecting. So this is going to be really useful. So make sure you remember this so that when we start doing our looping, we can utilize this, because we don't want to hard code in like a 2 and a 3. This is going to be a much better workflow, less mistakes possible, so that we don't accidentally get out of range. All right, so I think that's good for practice 2. Let's work with practice 3. Create a 2D array of ints and use nested for loops to fill it with random numbers. So it looks like 3 and 4 kind of go together. So maybe I'll just make one new function for this, because we're going to, in 3, we're going to create it. And then 4, we're going to use a for each to concatenate it. So let's kind of, be a little bit more forward thinking, and let me comment out these so that they won't run. And I'm going to close these up. And let's make a new function called array practice, since it's going to be both of those. And I'll define that down here. Private void array practice. And let's double check. Do we create a 2D array? We don't say how many we need, but since we're going to be printing it to the console, let's not make it too big. Why don't we do a 4x3? That'll give us 12 numbers, and that won't be too long to look at. So let's define our array first. Int, square brackets with a comma in there. We'll call it my array is equal to new int, and we said 4x3. So let's go through and make a nested for loop. So think about when, this was several weeks ago when we started doing looping, and we did while loops, and we used nested looping to create that grid of cubes in Unity where we had like the X and the Z. This is still kind of the same concept if you want to think about it in your head, but instead of, instantiating cubes in a scene, we're going to be stepping through an array so that we hit all of those elements. If you remember, like that diagram that I did in Photoshop, and we just fill them one by one in a nice organized fashion. So if we want to think of them as kind of like an X and kind of as like a Y, we can use those a little bit to think a little bit, we're going to say this first one is X, as far as our variable, and the second one is Y. And you just have to think of which way do you want to step through it. Do you want to go through and fill it row by row or column by column? A lot of times you might be needing to fill in your data row by row rather than column by column, since usually the columns kind of correlate. The rows are like a group of data. So this would be kind of like if we had 4 characters in a game and they have 3 stats. And we're going to kind of do that a little bit later as kind of a hint, but you can kind of think of it this way. 4 characters, 3 stats, hit points, magic points, and defense points or something like that. So, we don't want to give everyone defense points first necessarily. We might be filling it out character by character. So with that said, since this is X and Y, we actually need to set up the Y loop first. And I'll kind of diagram this out once I'm done typing all the code in so you understand why we're doing it this way. So we'll say for int y is equal to 0, because remember, elements start at 0. Y is less than my array dot get length. And since we're trying to look at this one, we're going to say, put our parentheses and put 1 in there. Then just y plus plus. Then we are going to do our X for loop for this one. So we'll say for int X is, still starting at 0. X is less than my array dot get length. And we'll put 0 in our parentheses because we are looking for that first number, X plus plus. Now we can finally access our array and put that information in there. So let's just access that array for X and Y. So it'll just be my array, then in our square brackets, x comma y is equal to random dot range. And we're just going to do 1 comma 10. So we'll just do, basically 1 through 9, those digits. And that is it for filling this. But give me a second. I'm going to pop Photoshop open, and we're going to kind of look at exactly what this is doing as it runs. So what I'm going to do is I'm going to visually draw this, and then we're going to pretend that we're the computer and we're going to run through this just so maybe it'll be a little bit more, it'll be easier to understand what exactly we're doing with this looping and why it's set up this way. It's possible in some instances you might need to set it up the opposite way, where you are going through column by column rather than row by row. So let's first draw this out. We are doing a 4 by 3. So we initialize our array, and we are getting 4 rows. So make this a little longer. So here's our array. 4 rows. 3 columns. And we can write our element numbers next to them just to keep these straight. So this is 0, 1, 2, 3. This would be 0, 1, and 2. Okay, so it's created. Let's now fill it. We'll pretend we're the computer and we'll fill it. So let me see if I can kind of get these both on the same screen a little bit. It might be easier. Photoshop can be kind of large. Let's minimize some of this. Sorry, let me get this a little bit better. There we go. Hide that, and I'll get this already here. Oop, let me make this a little bit, it's a little bit too small. Let's go to 150. And I can make it bigger. Switch that up. There we go. Okay, hopefully you can see it all. So let's actually write, so we created this. I now created my y variable. So we'll put, where can I put this? Let me move, sorry. Let me grab this layer and move it up a little bit. Oh, come on. Move that there, and we create our y. So y is here, and we set it equal to 0. We then create our x, and we set that equal to 0. And then we go into here. We say my array at x, y, so 0, 0 is equal to a random number. So this is our x, if you kind of think of it like as a graph. This is our y. So 0, 0. We will fill in here a random number, so 2. X gets changed to 1. Oh shoot, I did this backwards. Okay, sorry about that. I guess we're filling it column by column. I didn't think about this too. Okay. Good lesson on why we draw these out, because I did make a mistake, and I'm sorry. We are doing it column by column rather than row by row. But let's keep working through this, and then we will fix this, because I did want to do it row by row. This is why it can be good to diagram these out, because I did make a mistake, and people do make mistakes, and I'll show you how to fix this. Okay, so 1 goes to here. Y is still 0. We'll give it a random number. This changes to 2. 2 and 0, we'll give it another random number. This changes to 3, and we'll give it another random number. We're now done with this for loop. So x goes away. Y gets raised to 1. X starts at 0 again because we go back into it. So we now are at 0 and 1. And this is where the problem is. We didn't want to do it column by column, we want to do it row by row. So diagramming can be useful to make sure that you are working in the method that you want. And this isn't what we wanted. We wanted to do it row by row. So let's go and fix that real quick. This is a really quick fix with our code, and then we will step through it again. You know, not the whole thing, just most of it. So all we need to do is kind of flip-flop the X and the Y. And since we did do it in a really not hard-coded way, this is just a couple of fixes. So we actually want our first for loop to be X. Sorry, X. So we'd want myArray.getLength to be 0. And then this just has to get changed to X. Then in here, we would change this one to Y. Oops, that one needs to be X2. Change this to Y. Get length would be 1. X++ needs to be Y++. So the changes, the first one should say int X is equal to 0. X is less than myArray.getLength 0, X++. The inside one is int Y is equal to 0. Y is less than myArray.getLength 1, Y++. This stays exactly the same though. We don't need to make those changes. So let's go back and see how this is different now. See if we fixed our problem. Let me erase these. Let me get this set back up. A little bit better. Maybe a little bit bigger. There we go. Let me erase those. And let's try this again. Let's see how this steps through. All right, so X is equal to 0. So that's our first one, so we got that. Y is equal to 0. We got that. So we go into our first one, X, Y, so 0, 0. So that's still this first element, and we'll give it a random number. Y gets raised by 1. X is still 0. So now X 0, Y 1. We'll give it another random number. Y gets raised to 2. X is still 0. Y is 2. We'll give it another random number. We then are done with this first iteration. So Y disappears. This all goes away. X gets raised by 1. Y initializes again, starts at 0. X is 1, Y is 0. Y gets raised, Y gets raised, and we are now done with this for loop of Y. X gets raised again, and we would still keep filling it in. So even though we made a mistake, since we took the opportunity to go in and actually see what the code was doing, we were able to catch it. And we were able to go back and fix our problem before it became an issue, you know, with our data. Because maybe we did need to fill it in specifically this way with how the information was going to go in. And if we had let that go on, we would have possibly been trying to figure out why our output is not what we were expecting. So please take the opportunity to try to do this. Even if you feel you're confident, this only, if you have a piece of scratch paper, only takes a couple seconds. And it can sometimes be a useful tool to get your head wrapped around it. All right, so we are done with problem 3. We need to move on to problem 4, where we're going to use a for each loop to concatenate all of the numbers in a previously made array and display them. So let me get out of Photoshop. Actually, just in case I need it again, let me just minimize it so I'm not spending time reopening that. But we used for each loops last week to do something very similar. And what we're going to do is, it's going to be in a similar way, but as a reminder, we can use for each loops to do stuff like this, where we can read the data in our array, but we can't alter the data in that array. So if we wanted to try to fill it using a for each loop, it's not going to work. That's why we have to do this nested for loop. So this is a really good example. I would definitely keep this for your notes on how to step through an array where you're going row by row. So we'll just go below this because we're doing this all in the same question. The same function. So we're going to go below and we're going to get our string to print. So we're going to make a new string variable called toPrint. And we're going to set that equal to nothing. This is an important step because we want to, we want it to exist, but we want to make sure that there's nothing actually in the string since we're going to be doing concatenation. So to set up our for each loop, it's just like last week. So we'll say for each, and then what are we working with? Int number in my array, because it's what type of array is this? What do we want to call that element that we're working with? In what array are we actually stepping through? We can then just do toPrint plus equals, actually let's just do it, I'll do it all the way out, equals toPrint plus number, and I do want to add a space just so that we're not cramming all those numbers together. And one thing I do want to do before this, just so we can see a little bit better of what's going on, is I want to kind of force certain numbers into this array, just so it'll be a little bit easier to see what that for each loop is doing. So I'm going to access that array. We're going to fill it first with those random numbers, but I want to make sure that that first element is equal to -1, because that'll be an easy number to pick out from that array. I want that last first row, last column to be equal to -2. I want the last row, first spot, to be equal to -3. And I want the very last element to be equal to -4. And the only reason I'm doing this is so that we can easily see how the for each loop iterates through this array. I think it'll be like a really interesting thing to see, what is the first element? Where does that appear in this concatenation? Where does the last element in the row? So where is the last row beginning and where is the last row ending? So let's save it. Oops, sorry, forgot. We need to actually print that to the console. Don't forget that step. There we go. Save it. And oops, I'm getting an error. I forgot a semicolon. Where did I forget that? Oops, sorry about that. Hop over to here. And we're good to go. Okay, let's run this. Okay, so let's look at this information. So it goes -1, 5, -2, 5, 2, 9, 4, 9, 7, -3, 9, and -4. So what we can deduce from this is if we're looking at this and we kind of fill in that information real quick of how this got, let's erase these. real quick. And let's fill this in, and we can kind of work backwards on how the for each loop ran. Because we know we forced it to be -1 right here. And we forced it to be -2 right here. We forced it to be -3 right here. And we forced it to be -4 right here. Since that's what it is right there. So if we come back and we look at what the console printed, -1, 5, -2, 5, 2, 9, 4, 9, 7, -3, 9, -4. So this is the order it reads it. It steps through the rows. So it does, row 0, column 0, row 0, column 1. So the same order that we did set up that for loop. And that's not like it's not, I don't want to say it's not a coincidence. It's not like, oh, because we filled it that way, that's why the for each loop ran that way. No, this is the order that it always reads it. It starts with, X is 0, reads all the columns. X is 1, reads all the columns. So keep that in mind with how you set up your, when you're using a for each loop, is it's always going to run this way. And you can deal with your data coming out of it, that way. But that also might influence the way that you create your arrays and fill your arrays, knowing that it goes row, it reads it row by row, not column by column. And that is it for this part of the worksheet. Let's double check. Yes, so we did 1, 2, 3, and 4. I'm going to stop the video here, and I am going to just do a new video for question 5. So look for part 2 of this video.